What is up, folks? Is Mr. Walker coming back at it again with another video about logs. So, let's talk about some rules to help us solve them and just expand on what we talked about in our last video. So, first off, what rules help us to solve equations? We've been solving equations, since about, middle school, probably a little bit before that. So, what are two things that we use to help us solve equations? First off, we got inverse operations. Let's actually type inverse in, right? So we got inverse operations, and we also know that we perform the same operation on each side. Okay, those are things that we've been doing since, I don't know, a billion years at this point. Now, we got to know our inverses, addition and subtraction are inverses, multiplication, division, squaring something, square rooting. So what's the inverse of an exponent? That is a logarithm. Now, how does that help me solve an equation with a variable in the exponent? Case in point, all we got to do is take the log of both sides. Now, that's going to help us out with all of our different logs here. Now, just as a quick warm up, we've already solved equations a billion times in the past. You know the opposite of these different things at this point. It's also important that we go through and check our answer. If you don't check your answer, it's going to be a lot, okay? Especially when we're dealing with logs. You got to really start going through and checking stuff, okay, people? Oh, that's supposed to be a 5. See, that's why we got to check them. So 2 times 5, that's 10, minus 3 is 7. Check-a-roni. All right, let's get into some stuff that we can help us check it out, okay? Now, I'm going to give you most of the stuff as practice over here on the inside of this. But before we do, let's talk about, just a little bit before we jump into it, okay? All right, so first off, why does taking the log of both sides help you, okay? For this, it's important for us to know. I'll actually type this out because that'll be quicker. When we take the log of both sides, it allows you to move the variable out of the exponent to solve. Okay, so in cases like this where you have a base and you're being taken it from something that is, uh, sorry, if you have a base here and your answer is not traditionally a part of its times table, you have to take the log of both sides to really help you out with this. This is because this power here, x, this is a decimal. So we have to be able to go through and figure out what that decimal could possibly be. So first step, we take the log of both sides here, 3 to the x, and the log of 10. Now, when you deal with this, any exponents that are up here in your original problem will float in front as a coefficient instead. So it turns from log of 3 to the x to x in front. Now we got log of 3. Now, things to note, x here, your exponent, is separate from log of 3 because these two are multiplying now. Over here, we got log of 10 as it was before. We divide both sides here by that log of 3. And that should give us x here, and it's equal to the result of this division. Now, like I said in the last video, you're going to need your calculator. Stop not using your calculator, people. So let's get this going. We're going to turn it on. Let's clear out some of this jazz. We got log of 10 divided by log of 3. And that gives us this right here, 2.0959 something something. For us, we're going to typically try to resolve this as rounding to the hundredths place. All right. It's a lot to write all these decimals in there, but it's important to note if you're checking this problem, check it with the original answer before you check it with the rounded one. The rounded one's going to probably bump your answer up a little bit. So I just want to make sure that you are aware that when we check it, you want to go through and evaluate the answer from this. So if you had typed out this top line here, the way it is, and you got this decimal, to pull up the answer, you hit the second button and the minus sign, the one that's right next to the enter. Now that'll pull up the answer. And this is just a shorthand way of taking whatever you had here and just putting it into this. Now this gives us exactly 10. If you tried to do this to the rounded version of the decimal, which for us is going to be 2.10, if you do 2.10, you're probably going to get close by 10. You might go a little bit past it because this is higher than our original decimal is. Okay. So just be in mind, keep that in mind. When you're checking your answer, check with the original decimal, not your rounded one. Okay. So let's get a couple bits of math in here. All right. We got a little bit of everything here. So we're going to do 3 problems together. I'm going to do top left one, middle of the right, and we'll do bottom left. And I'll leave the other 3 for you guys. Okay. All right. So we got 7 to the x equals 35. Now, obviously, 7 to any power that's a whole number is going to get you a little bit past 35. I know 7 to the first is 7, 7 to the second is 49. So this x has to be a decimal. So in order to find x, we take the log of our answer, so log of 35, and we divide it by the log of our base. So let's hit that up. All right, where is the calculator? There we go. Let's go. Let's actually smallen this up. Okay, cool. Should be able to still see that. So we got the log of 35 divided by the log of 7. All right, that gives you 1.827 such and such and such. We're going to round this to the hundredths place. So we're going to do x equals 1.83. Now, keep in mind, these are rounding. So when you check this, check your original decimal, not your rounded decimal. All right, what if you got some jazz going on with an equation? With this, we got to get first our base and our exponent by itself on one side of the equation and everything else to the other side. So we got negative 10 here. We got to move this to the other side. So opposite of a negative 10 is a positive 1. Oops, sorry. All right, so on this side, these two cancel out, leaving 5 to the x by itself. On the other side, we got negative 10 plus, not negative 10, negative 3 plus 10, which gives us a positive 7. All right, keep in mind, this right here, so far, the pattern has been that these are decimals, especially when we're dealing with numbers that aren't traditionally gotten through our times table. So you have to be fine with getting the decimal, be fine with rounding, all right? So, same steps as before. X, our exponent, will be equal to the log of our answer over the log of our base. So, let's hit this up. We got the log of our answer, 7, divided by the log of our base, 5. This right here, that is our decimal place. Now, it's gonna round this up. That would be 1.2. Was that 1 that was gonna be there? Yep, 2, 1. So that'll be your power. Okay. All right. Same steps as, oops, sorry. Same steps as before. We got this time a whole lot more jazz popping off up here. Now, keep in mind, when we do our trick with the log, that is giving us this exponent. Okay. So x minus 3 is our exponent that we're going to get when we take the log of our answer, 10, and divide it by the log of our base, 6. Now, with this happening, it's important to know you are going to have a third step that's going to happen after this. Okay, so let's do this math. We got log of 10 divided by log of 6. All right, gives us all of what we have here. All right, so we're going to round this. Well, we're not going to round this just yet, actually. So let's write this out. It's important for us to know, don't round until you get to the very end because that'll change up your answer. So this is going to be 1.285097209. I'm writing all of this because I don't want to goof this up just yet. So next step, I got to move the 3 to the other side by adding. And once we add that 3 over, now we can start rounding. So 3 plus 1, that gives us a 4. I'm going to round this to the hundredths place. So that's going to be rounding the 8 using a 5, which will make this 4.29. Now, if you check this decimal in our calculator, this should at least work. So let's operate with that. Let's add the 3. Gives us all this. Now, if I take 6 and raise it, oops, sorry. 6 and raise it to our answer. That's not. Ooh. Hold up. Um, Hold up. Let me walk this back a bit. Hello, folks. Sorry about that. I had to check some math off screen, but I wanted to come back as you might be a little confused as to what this x is. Now, this x is the actual final answer, but it's important to know that this isn't the final exponent, okay? This is just what x equals here. If you ran this into there, this part right here that we did, this is the actual exponent that takes 6 to the power and gets us 10. But if you have an extra bit of work that you have, like how we do here with the 3, you would actually just go through and finish mathing that out. Now, please note, when I went through and I checked this, I probably, bugged you and myself out. But it's important to know when we did that original log of base 10 divided by log of 6, this is the actual exponent that takes 6 to the power of this to get to 10. But if you have the math that you have to do in the equation after, you have to go through and do that to finally figure out what x is. Okay? So if you do have extra math like how we did here, solve the math, bring it back into there. All right? Folks, I'm going to leave the other 3 for you. If you got any questions, if you see me in class, ask me that personally or try it out and I'll check it. Thanks for watching. See you later.